Dear students, now let us consider another important result that is depends upon the Gauss lemma. Let m be the number of least positive residues of the numbers n, 2n, etc. up to p minus 1 by 2n. So this m exceeds p by 2. Then m is given by m complements to sigma t ranges from 1 to p minus 1 by 2, greatest integer tn by p plus n minus 1 into p square minus 1 by 8 mod 2. So this theorem heavily depends upon Gauss lemma. Here m is also defined as like in Gauss lemma. What is m? m be the number of least positive residues of the numbers 1 and 2n etc. p minus 1 by 2n, which exceeds p by 2. Then m complements to sigma t ranges from 1 to p minus 1 by 2, p minus 1 all divided by 2. Greatest integer tn by p plus n minus 1 p square minus 1 by 8 mod 2. How to prove this one? The proof is, first you consider what is a is given. Let a equals a1 etc. a2, where or let you can define this a equals a1 etc. ak, where ai less than p by 2. Okay. Now take a typical number tn. Take a typical number tn and suppose tn divided by p. Then tn by p is written as, it is greatest integer tn by p plus greatest integer part tn by p plus the fraction part tn by p. Why? Because we know that what is 8 by 3? Consider this 8 by 3. 8 by 3 is nothing but greatest integer of 8 by 3 plus fraction part of 8 by 3. Greatest integer 8 by 3 means 2 plus this fraction part of 8 by 3. Okay, so it is what is fraction part 8 by 3? Then the remaining 8 by 3. If you divide 8 by 3, 2 into yes, it is a 2, but a fraction part of 8 by 3 is 2 by 3. Agreed. So 8 by 3 is nothing but 2 plus 2 by 3. That is, it can be expressed as greatest integer part 8 by 3 plus or integer part 8 by 3 plus fraction part 8 by 3. So like that, tn by p equals greatest integer tn by p plus fraction part tn by p, such that 0 less than fraction part tn by p strictly less than 1. So again 8 by 3 equals greatest integer 8 by 3 plus fraction part 8 by 3, integer part 8 by 3 plus fraction part 8 by 3. Clearly this 0 less than 8 by 3 less than 1. Fraction part of 8 by 3 less than 1. This is 2 by 3. 2 by 3 is always less than 1. So hence, if you consider typical number tn by p, then tn by p is integer part tn by p plus fraction part tn by p, where the 0 less than tn by p less than 1. So from here, what is tn? So that is means tn equals p into integer part tn by p plus p into fraction part tn by p. Agreed. So that means let it be p into fraction part tn by p is denoted as, suppose this part, this is denoted as some rt. So this is denoted as some rt. So this can be, then we have what is rt? Rt equals tn minus p into integer part tn by p. Okay, rt equals tn minus p into integer part tn by p, which is the least positive residue of t. which is the least positive residue of Tn mod P. Now, as in case of Gauss lemma, you can construct two of the sets. One is A1, A2, etc. Ak, and the other is one is set A equals A1, etc. Ak, comma B. What is B? B equals B1, etc. Bm. Okay, and then A and B are clearly we know that A and B are mutually disjoint. Why? Because this A 0 less than A less than P by 2 and this P by 2 strictly less than BG. So clearly this A intersection B is empty, means A and B are mutually disjoint. And A contains, that means A contains the least positive residues of the numbers n, 2n, 3n, etc. P minus 1 by 2n, where A less than B by 2, and B consists of the number of least positive residues of n, 2n, 3n, etc. P minus 1 by 2n, where P by 2 less than Bg. So from here, that means so it is R1, R2, etc. R P minus 1 by 2. Here T ranges from 1 to P minus 1 by 2. So this Rp is nothing but the least positive residues of Tn mod P. Tn means a number which is a particular number chosen from 1 and 2n, etc. P minus 1 by 2n. So this R1, R2, etc. Rp minus 1 by 2 is nothing but set R1, R2, etc. P minus 1 by 2 is nothing but A union B. What is A union B? A union B equals set of all A1, etc. Ak, comma B1, etc. Bm. Agreed. But we have, again you can construct the C like in Gauss lemma. C equals some C1, etc. Cm, where Cj equals P minus of Bg. Then we already proved that this A and the C are mutually disjoint. But A union C, which consists of the elements on the integers from where to where, closed interval 1 to P minus 1 by 2, like in Gauss lemma. Therefore, but also A union C consists of the elements A1, etc. Ak, C1, etc. C. Agreed. So we know that set 1, 2, 3, etc. to P minus 1 by 2, which equals A union C. A union C means it is A1, etc. Ak, comma C1, etc. Cm. Agreed. Now, so from here, what about 1 plus 2 plus 3 plus etc. plus P minus 1 by 2? 1 plus 2 plus 3 plus etc. plus P minus 1 by 2. Moreover, again, R1 plus R2 plus etc. plus Rp minus 1 by 2. You can add the elements in this set. That is sigma Rt, where T ranges from 1 to P minus 1 by 2. R1 plus R2 plus etc. plus R P minus 1 by 2 equals sigma I ranges from 1 to K Ai plus sigma J ranges from 1 to M Bg, A1 etc. Ak plus B1 etc. B. Agreed. Okay. From here, sigma T ranges from 1 to P minus 1 by 2 of T, 1 plus 2 plus 3 plus etc. plus P minus 1 by 2. That equals, again, sigma I ranges from 1 to K I plus sigma J ranges from 1 to N Cg. Sigma J ranges from 1 to M Cg means it is sigma J ranges from 1 to M. What is Cg? P minus of Bg. Agree. So that is nothing but sigma K ranges from, I ranges from 1 to K of Ai plus, if you distribute the sigma, since P is independent of this J, it is P into sigma J ranges from 1 to M of 1. Sigma J ranges from 1 to M of 1 means that is M and 1 in M times. So that term is P into M, that is MP minus sigma J ranges from 1 to M Bg. Agreed. So sigma T ranges from 1 to P minus 1 by 2 Rt is nothing but this one, and sigma T ranges from 1 to P minus 1 by 2 of T is nothing but this one. Agreed. Now, but we know that. What is RT? RT is this one. RT equals Tn minus P into integer part of Tn by P. So, putting sigma, if you take a sigma on both sides of this result, we know that sigma RT, where again T ranges from 1 to P minus 1 by 2 equals sigma Tn minus P into minus sigma P into integer part Tn by P. Okay. T into where again here T also ranges from 1 to where 1 to P minus 1 by 2. Enough. So sigma T ranges from 1 to P minus 1 by 2 RT. But what about that one? That is sigma AI plus sigma BG. Enough. So this sum is nothing but sigma AI plus sigma BG, where I ranges from 1 to K and J ranges from 1 to U. Why? Because we know that sigma T ranges from 1 to P minus 1 by 2 of RT is nothing but this one. Agree? So we have this result. That is sigma T ranges from 1 to N, Tn minus sigma this P of this one equals is nothing but it is sigma AI plus sigma BG. Agree? Now, but we know that what is sigma T? Sigma T equals, we know that sigma T. What is sigma T? Sigma T equals sigma AI plus MP minus BJ. So this one. Sigma T equals. This is our next result. Next equation. Sigma T ranges from P minus 1 by 2 of T equals sigma I ranges from 1 to K AI plus sigma plus MP minus sigma J ranges from 1 to N Bj, and sigma T ranges from 1 to P minus 1 by 2 Tn minus of this one equals this one. You can add vertically. What you get? Add this one means this is equation 1 and this is equation 2. 1 plus 2. So 1 plus 2 gives. 1 plus 2 gives. On left side it is sigma T ranges from 1 to P minus 1 by 2 T plus sigma T ranges from 1 to P minus 1 by 2 Tn minus P into sigma T ranges from 1 to P minus 1 by 2 integer part Tn by P equals what you get? Sigma AI plus sigma AI. It is 2 into sigma AI, where I ranges from 1 to K minus sigma J ranges from 1 to M Bj, and these two terms are cancelling each other, plus PM or MP. Agree? Okay. Now again, what is so now consider sigma T ranges from 1 to P minus 1 by 2 T. Actually, what is that one? That is 1 plus 2 plus etc. plus P minus 1 by 2. It is sum of the first P minus 1 by 2 natural numbers. So it is n into n plus 1 by 2. So we see that it is P square minus 1 by h. Enough. So means this gives P square minus 1 by, so sigma T means it is P square minus 1 by h. Agreed. So this implies, so this result become, it is MP plus 2 into sigma I ranges from 1 to K of AI equals, what is this one? This is P square minus 1 by h sigma T. Enough. Plus, yes, it is plus again, or before going to that one, it is before going to this one. So consider, this can be again rearranged there, sorry. Here T is commonly taken outside. Agreed. So it becomes n plus 1 into sigma T ranges from 1 to P minus 1 by 2. N plus 1 into, here T is sigma T ranges from 1 to P minus 1 by 2 is common. So it is n plus 1 into sigma T ranges from 1 to P minus 1 by 2 T minus P into sigma T ranges from 1 to P minus 1 by 2 integer part Tn by P equals 2 into sigma AA plus Pm, where I ranges from 1 to k. So that means it is MP or PM plus sigma I ranges from 1 to k to AA or 2 into AA, right side, equals, we know that sigma t ranges from 1 to p minus 1 by 2, t is 1 plus 2 plus etc. plus p minus 1 by 2, it is p square minus 1 by 8. So it is n plus 1 into p square minus 1 by 8 minus p into sigma t ranges from 1 to p minus 1 by 2 integer part tn by p. Now, but we know that. What is n plus 1? We know that n plus 1 is always congruent to n minus 1 mod 2. N plus 1 is always congruent to n minus 1 mod 2. Agreed? Okay. And p always congruent to 1 mod 2, or p minus 1 is always, or means p always congruent to 1 mod 2. Why? Because p is an odd prime. So p minus 1 is always even, means it is a multiple of 2. Hence p is always congruent to 1 mod 2. Since p is congruent to 1 mod 2 and n plus 1 is congruent to n minus 1 mod 2, also p is congruent to 1 mod 2. So from here what do you get? So from here we have m congruent to, it is m congruent to n minus 1 into p square minus 1 by 8 plus sigma t ranges from 1 to p minus 1 by 2 integer part tn by p into mod 2. Okay, why? Because p is always congruent to 1 mod 2. So, and this 2 is 2 into sigma I ranges from 1 to k. This is always, this is a multiple of 2. This is also a multiple of 2. So finally, this m is congruent to n minus 1 into p square minus 1 by 8 plus sigma t ranges from 1 to p minus 1 by 2 integer part tn by p mod 2. So this is our result. Okay. Now, suppose n is even, what happens here? That's the special case of this result. When n is even means, what is n minus 1? This n, when n is odd, not even, when n is odd, means n equals to k plus 1. When n is odd, this n minus 1 is always even, means this n minus 1 is a multiple of 2. Hence n minus 1 into p square minus 1 by 8 is also a multiple of 2. Therefore, when n is odd, this result reduces to m congruent to sigma t ranges from 1 to p minus 1 by 2 integer part tn by p mod 2. Okay, so this is the consequence of this result. When n is odd, it is m congruent to sigma t ranges from 1 to p minus 1 by 2 greatest integer tn by p mod 2. So means this result heavily depends upon Gauss lemma. Agreed.